So I'm Carolina KLOCK. I'm from Brazil, but I'm currently doing a PhD at Ghent University. I'm gonna take you guys a lot back than what we've been talking about in this conference, something like 400 million years ago. And I'm gonna talk about a series of unfortunate Silurian events. Okay. So when I'm talking about events, I'm talking about biogeochemical events, which means there's not a proper definition about these biogeochemical events, but normally it involves a biotic turnover, which comes with extinction of taxa or faunal turnover, and that can happen in the benthic realm, which are the life in the substrate, or in the pelagic realm, which are the things floating around or swimming around. This can happen as, it's also marked by perturbations in the carbon cycle, which happen as the position of microbial carbonates widespread. And on the rock record, we also see stable carbon isotope positive excursions marking these perturbations. Another factor to take into account that marks these biogeochemical events is ocean anoxia. We see ocean anoxia nowadays to a lesser extent in the Gulf of Mexico and in the Baltic Sea. And what are the footprints of ocean anoxia in the rock record? So it's the deposition of black shales in shallow waters. And we also traced teratology as a reflection of this ocean anoxia because of the high metal content. Plankton starts to become malformed. And it's interesting because the other way around is a good argument to show if we have the malformed plankton and we have higher metal content on those individuals, it means that the high metal content is primary. It's not post-deposition. And people have observed these malformations, these teratological plankton in several of the Silurian events. I'm particularly studying chitinozoans, which are organic wild microfossils with uncertain biological affinity. So we don't know, we have no idea what they are. We still study them. This is a normal chitinozoan. This is a malformed teratological chitinozoan. And for the sake of comparison, in the Cenozoic compresses over 60 million years, and there's almost no stable carbon isotope variability in it. When it happens, it only goes up to +2 per thousand. But then if we take it to the Silurian, then we see that in less than 25 million years, there are 9 stable carbon isotope excursions that also mark biogeochemical events. And these excursions go up to +12 per thousand. So they are huge if we compare to what we see in more recent times. There are 3 events in the Silurian that are more broadly studied. They are the Lau event, the Mode, and the Eurasian. And the remaining events, they have been either more recently described or they have been studied to a lesser extent. For my PhD, I'm focusing on the Mode event and on the Valgo event, one more broadly studied, another one that remains more of a mystery. Our group here in Ghent is also studying other events such as the Eurasian and the Lau. And there is actually my colleague, Finn, who is presenting a poster on the late Iranian event and on the early Iranian events in this Congress. So I highly recommend everyone to check it out and see what it's about. So for the Valgo event, because this event has not been so broadly studied, we don't know how much it affected the biota and just life in general. But we use microfossils because they provide the best record to assess the effect of these biogeochemical events in life. Because for a very small amount of rock, you get many fossils. So that allows you to do to play with the numbers, to do kind of a more robust statistics rather than if you were looking at fish or brachiopods, that you would need to look at a lot more rock to get a better sense of it. And so my PhD project is actually one of the first to look into detail at the microfossils during these events. The stable carbon excursion of the Valgo event goes to up to +4 per thousand. We see black shales are reported in shallow waters during the event. And this I'm very proud to present here because these are malformed chitinozoans. The malformed one is to the right and the normal chitinozoan is to the left. Preservation is not as pretty as the other ones I showed in the beginning. But I found these in the Michigan Basin and they are still unpublished. And these are the first malformations reported ever in the Valgo event, even though we expect them, but it's always nice to find them, obviously. For the Molde event, which is more broadly studied, it's known for having extinguished up to 95% of bractolite species. But it also affected radiolarians, acritarchs, chitinozoans, nautiloid cephalopods, conodonts, and fish. The excursion goes up to +5 per thousand. And we observe the carbonate factor going crazy with pinnacle reef successions. So it's these microbial carbonates that form in a column. And we see successions after successions of them during this event. We also see the deposition of black shales. And up until 1 week ago, the only report or any sign of teratology in the Molde event was by the miniaturization of brittle stars. And miniaturization is a form of teratology. But then 1 week ago or 2 weeks ago, I found this beauty here. That is a gorgeous malformed chitinozoan related to the event. So for the conclusions, what is the takeout message of this presentation? I think the first thing is that the Silurian period was very eventful. It's only 25 million years, but a lot was going on then. And regarding these biogeochemical events, I think we need to start establishing a definition for what they mean. But it is really hard to define and fully comprehend them, especially because we are talking about an incomplete rock record of 400 million years old. However, our approach is very novel and also challenging because we are trying to integrate paleontology, stratigraphy, sedimentology, and geochemistry. So we are hoping with all these tools, we can provide a better picture of how things happen then. And also with new technologies come new possibilities, and we are trying to take advantage of that, especially for the geochemical analysis. My ongoing work for my PhD, I'm looking at well-constrained sections, meaning we know the age of the section, we know like stratigraphically where they are situated. And we are looking at chitinozoan response to environmental disturbances in these sections around the world, referring to the Molde and the Valgo event. I'm also looking for my malformations in chitinozoans associated with these events, and I'm also looking at the rock chemistry on them. And finally, we also collected on a field trip to Anticosti in Canada, brachiopods for strong shoe isotopes, to look throughout the Valgo event then, and then I also collected in Sweden to look at the Molde event. And we used micro drilling to look at the brachiopods, and it's just like these very modern and really cool techniques. This is a picture of me and Finn on the field in Anticosti. And thank you all for watching and hanging there for the last presentation.